let's start. We want to prove that the limit as x approaches 4 of x plus 2 is 6. So what we're going to start with is, our goal is to find delta, so then we can start the proof. So we're going to start with the absolute value of f of x minus L less than epsilon. And then from there we're going to find the delta. So we want to have at the bottom absolute value of x minus 4 less than delta. Okay, and then we can start the proof. So let's see. We have f of x is x plus 2. L is my limit, which is 6 less than epsilon. Now I can do 2 minus 6, that's negative 4, and that's less than epsilon. So now we can compare. We both have an x minus 4, so obviously delta has to be epsilon, right? So we can choose delta to equal epsilon. So I'm going to start my proof now. I'm going to say the absolute value of x minus 4 is less than delta. And now delta we said is epsilon. And I can rewrite x minus 4 as absolute value x plus 2 minus 6 less than epsilon. And now we've shown that the absolute value of f of x minus my limit is less than epsilon. And the proof is complete. Okay, let's try another one. Let's say I have limit as x approaches negative 2 of 4x plus 5. I'm going to plug in x equals negative 2 and for x to get my limit as negative 3. Okay, now I'm going to start. So I want to get delta. So I'm going to start with absolute value f of x minus limit is less than epsilon. Okay, my function is 4x plus 5, and my limit is negative 3. So minus negative 3. And that's less than epsilon. The two negatives will give me a positive. So I can add these. I have 4x plus 8 less than epsilon. And I can pull out a 4. So I can have 4 times absolute value x plus 2 less than epsilon. And that will be absolute value of x plus 2 less than epsilon over 4. So we just divide both sides by 4. And now we have our delta. Right? So delta is going to be epsilon over 4. So we're going to let delta equal epsilon over 4. Well, we're going to start our proof now. We want x plus 2 to be less than delta. So if x plus 2 is less than delta, so delta we said is epsilon over 4. I'm going to multiply both sides by 4. So I have 4 times absolute value x plus 2 less than epsilon. And I'm going to distribute the 4 inside the absolute value. So it's going to be absolute value 4x plus 8 less than epsilon. And now I can rewrite this as 4x plus 5 minus negative 3. And my proof is complete because this is my f of x. This is my limit, and that's less than epsilon. So if the absolute value of x plus 2 is less than delta, then the absolute value of 4x plus 5 minus negative 3 is less than epsilon. So our proof is complete. Okay. All right, now let's look at limit as x approaches negative 4 of 1/2 x minus 1. To find my limit, I need to plug in x equals -4, so we get -3. The first step in this, before we do the proof, is to find delta. So we're going to look at absolute value f of x minus my limit being less than epsilon. So the function is 1/2 x minus 1. My limit we said is -3, and that's going to be less than epsilon. Now we have two negatives, that's going to be positive. So we'll have absolute value 1/2 x plus 2 less than epsilon. I can pull out a 1/2 outside the absolute value, and I'll have x plus 4 less than epsilon. And multiplying the 2 to the other side, we'll have x plus 4, and that will be less than 2 epsilon. Okay, and now we found our delta. And we can begin the proof. So we're going to let delta equal to epsilon. So if we have x plus 4 less than delta, where delta is 2 epsilon, we can divide both sides by 2 to get 1/2 absolute value x plus 4 less than epsilon. And now we can distribute the 1/2 inside the absolute value. So we'll get 1/2 x plus 2 less than epsilon. And we can rewrite this as absolute value 1/2 x minus 1 minus -3. And that's less than epsilon. And the reason I'm rewriting like this is because this is of the form absolute value of f of x, and this is minus my limit is less than epsilon. So if we have if absolute value of x plus 4 is less than delta, then absolute value 1/2 x minus 1 minus -3 is less than epsilon. So that concludes our proof. Okay. Let's say we have limit as x approaches 2, as x approaches 3, 3/4 x plus 1. I'm going to plug in x equals 3 here, so we'll get 9/4 plus 1, which will be 13/4. Okay, so that's our limit. Now I'm going to start again with f of x minus limit less than epsilon. My function is 3/4 x plus 1. My limit is 13/4. And that's going to be less than epsilon. I can simplify, so I have 3/4 x, and now it's 1 minus 13/4. And that's going to be -9/4. Less than epsilon. I can pull out a 3/4. So this one, I'm just going to leave it inside. It's a little tricky. And here I have to multiply by 3. And this 3/4 now, we can pull outside, and that will be 3/4. So it'll be positive. And we can multiply both sides by 4/3. So, and these will cancel. Multiply this by 4/3 as well. So we have absolute value of x minus 3 less than 4/3 times epsilon. So we'll choose delta to be 4/3 epsilon. So if we let delta equal 4/3 times epsilon, we want to start with x minus 3 being less than delta. So delta here we said is 4 over 3 times epsilon. I'm going to multiply both sides by 3 over 4 to get epsilon by itself. So the 4 and the 3 will cancel. And now the next step will be to distribute the 3/4 inside the absolute value. So it'll be 3/4 x minus 9 over 4 less than epsilon. And I'm going to break this up. I'm going to say it's 3/4 x, and I'm going to say plus 1 and minus 13 over 4 less than epsilon. And now what we showed is this is my f of x, this is my limit, and that's less than epsilon. So if x minus 3, if the absolute value of x minus 3 is less than delta, then the absolute value of f of x minus my limit is less than epsilon. So by the definition of the limit, we have proved this.